In today's lecture, I am going to talk about or I am going to estimate the ground state energy of hydrogen atom, and here I will use the variational method. I will not using the simple eigenvalue problem, right? So since ground state, so first of all let us estimate the wave function. So since ground state wave function of hydrogen atom has no nodes and vanishes at infinity, here I am talking about the radial part, radial wave function, right? So keeping this in mind, let us choose a trial wave function. Choose a trial wave function. So let me write down that psi is equal to a exponential minus alpha r. So this is our trial wave function which I am choosing, and here a is known as normalization constant. Normalization constant, and this alpha is a variational parameter. It is a variational parameter, right? So now our motive is to calculate the value, to estimate this a, means the normalization constant. So let us try to find out the value of this a. So since we know that wave function must be normalized, so that means scalar product of this must be equal to 0. I will use this to find normalization constant. Means psi star psi, its integral is always equal to 1, and let us do one thing, and dv is the small volume element, means I am integrating it over available volume. So it is 0 to infinity, 0 to 2 pi, 0 to pi and 0 to 2 pi. It is a star exponential of minus alpha r and a exponential of minus alpha r, and it's dv, but this dv can be written like this. So let us do one thing. This dv can be written in terms of spherical polar coordinates. So it is r square dr sine theta d theta and d phi. Means this is basically dv in terms of spherical polar coordinates. That's what I am doing here, right? So this is in terms of spherical polar coordinates. Now let us try to simplify it. So it is a star a. Let me write down radial part r square exponential of minus 2 alpha r. I put these two together, right? And it's dr, and its integral from 0 to infinity, and its integral 0 to pi sine theta d theta, and it is integral from 0 to 2 pi d phi, and its value, this integral will become 2 and this integral will become 2 pi. So overall their product will become 4 pi, right? So let me put down their values here. So I can write down this as this a mod square 4 pi integral 0 to 2 pi, it is r square exponential of minus 2 alpha r dr, it's equal to 1, And to find out its value, let us use a formula, that is, if I am having integral 0 to infinity and x raised to power n exponential of minus alpha x, then this integral is equal to n factorial over alpha raised to power n plus 1. So if I use this formula here, then I can write down this as, this is equal to a mod square 4 pi, it is 2 factorial over 2 alpha raised to power 2 plus 1, it's equal to 1. So that means I can simply write down that this a mod square 4 pi let me go back. Yeah, so if I try to look at this part, then this is basically, it is 2 over 8 alpha cube, so it is 1 over 4 alpha cube. So if I put it here, then its 4 pi will remain as it is, and it is 1 over, let me change the, so it is 1 over 4 alpha cube is equal to 1. This 4 will cancel out with it. So from here I can write down that a square is equal to alpha cube over pi. So that means this a can be written as alpha raised to power 3 by 2 under the root pi. So we have to remember these two things. We will use these later on. So this is the value of this normalization constant. So let us now consider the Hamiltonian. Now consider the Hamiltonian of hydrogen atom. So Hamiltonian of hydrogen atom is equal to p square by 2m minus e square by r. So this is the kinetic energy term, and this, including negative sign, this is the potential energy term. And this in terms of del operator, and even let me try to express in terms of radial del operator. So h cross square del r square over 2m minus e square by r, and as we know that this del r square is equal to 1 over r square curly over curly r, and it is r square curly over curly r. So if I use this value here, then what I am getting, and I can write down h psi is equal to this h psi, it can be written as minus h cross square over 2m, and let me put its value here. So it is 1 over r square curly over curly r square curly over curly r, and minus e square by r, and psi will be outside. So if I put the value of psi will be a exponential of minus alpha. Let me write down it in this way, and let me multiply this wave function with this and this part. So I can write down it as, this is equal to minus h cross square by 2m, it's 1 over r square curly over curly r, it is r square curly over curly r, a exponential minus alpha r, right, and minus e square by r, a exponential of minus alpha r. So let me try to simplify this part. So if I try to simplify this, how it can be written as, this part can be written as 1 over r square curly over curly r square, it's like this, right, So r square curly over curly r a exponential of minus alpha r, right? So it is, this a can be taken outside, so a over r square, it's a over r square curly over curly r, as it is. This r square, it will remain as it is, right? Then what I can do, I have to take its derivative with respect to r, so it is a exponential minus alpha r, and minus alpha will again here, right? So it can be written like this. So it is, so it is equal to, now, yeah, okay, so it is a upon r square will remain as it is, so it is minus alpha, so it is okay, I have taken a from here outside, so that means this a should not be there. Let me correct it. This a should not be there, right? So it is a upon r square curly over curly r, so it is minus alpha r square exponential minus alpha r. So now I will apply product rule here, because one is this and another function will be this, and my this is one, then this is another. So let me apply the product rule here. So it is a upon r square, so it is minus alpha r square as it is, and its derivative exponential of minus alpha r, and minus alpha will remain as it is, plus its derivative will be minus 2 alpha r, and exponential of minus alpha r will remain as it is, right? So these are the two terms which are put like this. So it is a upon r square, it is alpha square, because both can be written together, so it is alpha square r square exponential of minus alpha r, and here it is minus 2 alpha r exponential of minus alpha r, right? So it can be written like this. So let us put its value back here. So therefore this h psi, it can be written as, this h psi, it can be written as minus h cross square by 2m a alpha square minus 2 alpha by r, because here this is the common term, so it can be taken outside. So if I take it outside, so it will become a upon r square, and let us multiply it with it. So this part can be written as this r square will cancel out with it, so it is a alpha square, and here it is minus 2 alpha upon r, right, because it gets multiplied here, and exponential of minus alpha r can be taken outside. So if I put it here, means here, then yeah, it can be written like this, right? H cross square over 2m a alpha square minus 2 alpha upon r, and here it is exponential minus alpha r minus e square over r a exponential of e raised to exponential of minus alpha r. That's what we are getting. So it can be taken outside, so it can be written like this: h square by 2m alpha square minus 2 alpha over r minus e square by r, and a exponential of minus alpha r, it can be taken here outside. So let me write down this now. So it is h cross square by 2m alpha square minus h cross square alpha over mr minus, sorry, it's plus, and it is e square by r, and it is a exponential of minus alpha r. That's what we are getting here. So let me rewrite down this as h square by 2m. The alpha square will also sitting with it, and plus h square alpha over m minus e square, and 1 by r can be taken outside from these two, and overall it can be written outside the exponential of minus alpha r. Now let us try to find out the expectation value of energy using this Hamiltonian. So to find out that, what do we do? This expectation value of energy, it can be written like this: psi h psi, and since the wave function is normalized, so its value will be 1. So therefore I can simply write down it like this. So let us put their values. So if I put their values, it's integral from 0 to infinity, 0 to pi, 0 to 2 pi, and here it is a star exponential of minus alpha r, and here inside it is h cross square by 2m alpha square plus h cross square alpha over m minus e square psi, sorry, 1 by r, it's here, and it is a exponential of minus alpha r. So here I can rewrite down this as, oh sorry, the volume is also, volume term will also be there, so it is yeah, r square dr sine theta d theta and d phi. So it's 0 to infinity, it is minus h cross square over 2m alpha square plus h cross square alpha by m minus e square 1 by r, right, and here it's a square exponential of minus 2 alpha r, and it is r square dr, and sine theta d theta integral from 0 to pi, and its integral from 0 to 2 pi, and it is d phi. And as we know that from earlier knowledge that its value, these two integrals leads to 4 pi, right. And as we know that a square is equal to alpha cube over pi. So let us use these two values here. So when I use these two values here, then the expectation value of E will be equal to 0 to infinity, it is minus h cross square alpha square by 2m plus h cross square alpha over m minus e square, it is 1 by r, and yeah, here it is alpha cube over m, sorry, alpha cube over pi, and exponential minus 2 alpha r square dr into 4 pi. Right, so let me rewrite down this equation again. This is equal to, it's 0 to infinity minus h cross square alpha square 2m alpha cube, means I multiplied this term with this term and then rest of this part, so it is alpha cube over pi exponential minus 2 alpha r square dr and 4 pi plus 0 to infinity, it is h cross square alpha over m minus e square 1 by r. It is alpha cube over pi exponential of minus 2 alpha r, and it is r square dr and 4 pi. Now this pi will cancel out with this, and this will cancel out with it, and similarly this r will cancel out with this 1r, and this pi will cancel out with this. So if I do this then and do little algebra, then what I am getting, this is equal to minus 2 h cross square alpha raised to power 5 over m, it is 0 to infinity r square exponential minus 2 alpha r dr plus 4 alpha cube and h cross square alpha over m minus e square, and here it is integral r exponential minus 2 alpha r dr, right? Now let us have a look at these two integrals, and this integral is again from 0 to infinity. So if I try to look at this integral and this integral, so this integral is 2 factorial 2 alpha raised to power 3, so it can be written as 1 over 4 alpha cube, and similarly it is 1 factorial over 2 alpha raised to power 2, so I can write down 1 over 4 alpha square. And for this I have used the formula which I described earlier, calculating these two, x raised to power n exponential of minus alpha x dx integral from 0 to infinity, it is equal to n factorial over alpha raised to power n plus 1. So I use this formula here, and if I use these values here, then this integral will become let me write down. So the expectation value of energy can be written like this. This is equal to minus h cross square alpha square over 2m plus h cross square alpha square by m minus alpha e square. So if I take LCM of these two, then this will be equal to h cross square alpha square by 2m minus alpha e square. So this is the expectation value of energy, but our objective is to find out this using variational principle. So applying variational principle, to find to find alpha. So here curly e over curly alpha must be equal to curly over curly alpha, and let us put its value h cross square alpha square by 2m minus alpha e square, and this must be equal to 0. So that means h cross square 2 alpha over 2m minus e square, it must be equal to 0. This will cancel out with it. So I can say that h cross square alpha over m minus e square is equal to 0. So from here h cross square alpha minus m e square over m is equal to 0. So that means this h cross square alpha minus m e square is equal to 0. So h cross square alpha is equal to m e square, so alpha can be written as m e square over h cross square, right? So this is the value of alpha. Also, let us recall some very interesting result, that is, as we know that A naught is equal to h cross square over me square. This is basically Bohr's radius and its value will be 0.5267 angstrom. So if I use this value, that means I can conclude from these two results that this alpha is equal to me square over h cross square, or it can be written as 1 over A naught. Therefore, E minimum, or corresponding to this value of alpha, can be written as h square 2m alpha square minus alpha e square at alpha is equal to me square over h cross square. It can be written like this. So it is h cross square 2m me square over h cross square whole square minus me square over h cross square into e square. So it is h cross square m square e raised to power 4 over h raised to power 4 over 2m. This m will cancel out with it, so this will cancel out with this, and here m e raised to power 4 over h cross square. So it is m e this and 2h cross square minus m e 4 me4 over 2h cross square minus me4 over h cross square. And let me simplify it taking LCM. So it is minus me 4 over 2h cross square. So therefore, minima of energy is equal to me4 over 2h cross square, or I can write down it as me square over h cross square, and it is e square by 2. It can be written separately, and this me square by this is equal to 1 by A naught. So I can write down it as minus 1 over E naught e square by 2. So therefore, this is the value of minima of energy, and the minima of energy which we are getting from here, that is 1 over A naught e square by 2, or it is minus me square by h cross square, or e square by 2. This is the exact eigenvalue. This is exact eigenvalue of ground state energy of hydrogen atom, and similarly we can find out the corresponding eigen wave function, and the eigen wave function we can write down it as psi is equal to alpha 3 by 2 over pi and exponential of minus alpha r. And if I put value of alpha is equal to 1 over A naught here, then it is 1 over pi A naught q under the root over exponential minus r by A naught. So this is the true or the exact eigenwave function, right? So it is the exact eigenwave function of hydrogen atom in ground state, right? So thus we have applied here the variational principle to find out the total energy, or the total ground state energy in the ground state wave function for the hydrogen atom. So that's all for this lecture. In the next lectures I will talk about different other applications of it, that is variational math.